All right, hi there. In this video, we're going to address topic 2.4, representing relationships between two quantitative variables. All right, our objectives are to represent bivariate quantitative data using scatter plots, and then to describe the characteristics of said scatter plots. Now, I know that already sounds like a very fancy word, bivariate. But it simply just means two variables, okay? And then quantitative, we know, refers to numerical data, right? Things that are recorded with numbers. So the type of data that we're gonna deal with are data where we have two numerical measurements, okay? So maybe it's like height and weight, or GPA and SAT score, but just two numerical measures for every individual. Okay. So actually, before I talk about the four characteristics, let's just look at a scatter plot. So here we have a data set about roller coasters, and we have a lot of different variables that were measured. The drop distance, the material, the height, the length, the speed. I think this is like descent angle, right? Okay. So, you know, I might be interested in how the height of the roller coaster is related to its speed, right? One might think, you know, the taller it is, the faster it goes, right? So let's just look at height. Okay, so I can pull height over here, and it'll just kind of separate it into two groups. Obviously, I know height is numerical. It can be expressed on the number line. Okay, so we can create a nice dot plot showing the varying heights of roller coasters. You know, this is 60 feet. And this one's about 460 feet. Okay. Now let's pull in our second variable, right? The second variable is going to be speed. And so we're going to pull that to the vertical axis. Okay, so it's going to separate it into two groups, you know, above 70 miles per hour or below 70 miles per hour. But speed can also be expressed on a number line. Okay, so now we have a number line for height. That's our x-axis. We have a number line for speed. That's our y-axis. And then now we have the points, right? Each point represents a different roller coaster displaying a pattern or a trend. Okay. And so I can click now on any one of these points and, you know, I can gather information, or maybe I want to use a line here. So this point lines up with about, I don't know, say 171 feet high, and its speed is about 105 miles per hour, right? So you can take any point and look at its coordinates to see what its measurements are for each variable. All right, when we graph scatter plots like this, when we create scatter plots, we normally put the explanatory variable on the x-axis. Okay, so I think that height probably could explain how fast a roller coaster goes, right? I would think the taller it is, the faster it goes. So since I think height is doing the explaining, I put it on the x-axis, and I think of speed as kind of the response, and it goes on the y-axis. Okay, so this is a scatter plot. Right. Let's go back to the presentation. So when we create a scatter plot, we want to describe four main characteristics of it. Okay. The first being direction, and then the form, the strength, and then any unusual features. So for direction, there's really two types of directions you might see, right? You might see a scatter plot where the points are trending down, okay? We call this negative association. And this just means that as the values of the x variable increase, the values of the y variable tend to decrease. So as one variable goes up, the other variable goes down. The other direction you might see is one that's like an upward trend, right? The points go from the lower left to the upper right. We call this positive association, okay? And the way you would interpret it is, you would say, as the values of x increase, the values of y tend to increase as well. And there may be instances where you don't really see any type of direction, right? And we would say no association here, right? The values of x and y don't seem to be related in a very meaningful way. All right, form. Right, so on the AP exam, there's two forms that you need to be able to recognize. The first, and probably more important, is linear forms, okay? So these are going to be patterns that look more or less straight, okay? So obviously scatterplot 2 is very straight, and scatterplots 4 and 6 are mostly straight. The other form that you are going to see in scatterplots is a curved form or a nonlinear form. Okay, and so we put a bunch of different forms together and say curved. So like scatterplot number 1 looks like it has an exponential pattern to it, right? Scatterplot number 3 looks more parabolic, and scatterplot number 5 maybe looks parabolic. Maybe we're looking at, you know, a portion of a sinusoidal curve, right? So anything that's any type of curve, we just call it curve. You don't have to, you know, describe the mathematical function that you think the curve is, like exponential or parabolic or cubic. You just have to simply say curved. Right, the third characteristic is strength. And so we need to describe how well the points fit a pattern or follow their pattern, okay? So in scatterplot number 1, the points are very tightly packed in and close to their pattern. So we would describe that as a strong relationship. Scatterplot number 2, well, the points are all spread out. You can barely even tell what the pattern is, so we would describe that as weak. And then for things in between, like scatterplot number 3, right, the points aren't like, they're not tightly packed together in a line, and they're not super spread out either. We would describe this as moderate. Okay, so just in terms of language, we have strong, weak, and moderate. Okay. And then the fourth and final characteristic is any unusual features. Okay, and so I pulled up 3 examples here of things unusual. Okay, so our first scatter plot is showing the relationship between the forearm circumference, forearm measurement, and height. Okay, both measured in centimeters. And as you would expect, right, the taller people tend to have longer arms or bigger arms, okay? But there's this one point here which seems unusual, right? This person has, you know, really long arms, but a relatively short height, okay? And so that person just does not fit the pattern, the trend that we see with the rest of the points, okay? So that's one type of unusual feature, are points that don't follow the pattern. Okay. Another one might be points that follow the pattern, such as this one, right? It follows this general upward trend, okay? But it just has a really large measurements, right? So the X value, the neck measurement is absurdly large, and the weight measurement is also extremely large relative to the rest of the individuals in the data set. Okay. So this point isn't unusual in the sense that it doesn't fit the pattern, right? Because it does follow this linear pattern or this trend. It's just extreme. Okay. And then another type of unusual feature that you'll encounter is clustering. Okay. So in this last graph, I know it's just, you know, an X and Y, but if I recall, the Y variable is like average lifespan, and the X variable is a measure of a country's wealth. So each dot represents a different country, okay? And so you can see that the points kind of separate into 2 clusters, right? And you can think of it as, you know, these are first world countries, right? They have high wealth and they tend to live long. And these are developing countries, okay? So they're not as wealthy, and, you know, average lifespan varies a bit more. All right, so points that don't follow the pattern, points that are extreme, and then clustering, right? These are the examples of unusual features that you'll see. All right, so let's go back to the roller coaster. Hopefully it's still up. And let's describe the 4 characteristics in this scatter plot. Okay. So first of all, I would say that there's positive association, right? The direction of the points is upward. Okay. So as the values of the height, as the height of roller coasters increase, the speed also tends to increase as well. Okay. Second would be the form, right? These points follow a pretty straight linear pattern. Okay. So I'd say that the form of this is linear. Okay. Next would be strength. I would probably describe this as pretty strong. The points are fairly packed in close together. Okay. I can, you know, it's not hard for me to imagine where the line would go, right? That represents the pattern. Okay. And then unusual features. You know, maybe this point that's already been clicked, it's highlighted here in blue. stands out just a little bit, right? It seems to be a little bit faster than what seems to be the pattern here. Okay. They're also, oh, well, yeah, maybe that's the only one that I would say stands out, and it's not even a big deal. It doesn't stray that far away. Right. So to summarize in a full sentence, we might say something like, there is a strong positive linear relationship between the height of a roller coaster and its speed. Okay. Taller roller coasters tend to have faster speeds. Okay. And then we may point out a couple roller coasters that may not fit the pattern.